Okay, how is everyone? Welcome to the World of Science Academy, okay, where we're going to discuss some new things in organic chemistry, okay? Okay, so in organic chemistry, we're just going to focus on one component which is called the isomers. Isomers of who? Alkanes. Isomers of alkane, because previously we discussed the hydrocarbons, which is the alcohols, the alkynes, the alkanes, the alkenes, and so forth. So in today's lesson, we're just going to focus on the isomers of who? Alkanes. Okay, so in the first place, we define alkanes. We defined alkanes as the hydrocarbons that have got a single bond between carbon to carbon and carbon to hydrogens. So those that is how we define the term alkane, meaning that there is a single bond between carbon to carbon and the carbon to hydrogen. Now, in today's lesson, I want us to focus on the isomers of alkanes. Okay? Isomers. Isomers of alkanes. So here we have got the isomers of alkane. So how do we define the term isomer? So first we need to define this one, which is called the isomers. So isomer is defined as the organic substance that has got the same molecular formula but different structural formula. That is how we define the term isomer. Okay? Okay, so that is how we define the term isomers. So they are organic compounds that have the same molecular formula but different structural formula here. So here, under this one, we are under alkanes. We have got 10 members of alkanes. One, we have got what we call the methane. That's number one. Number two, we have got ethane. Number three, we have got propane. Number 4, we have got butane. Number 5, we have got pentane. Number 6, we have got heptane. Number 7, we have got septane. Number 8, we have got octane. Number 9, we have got nonane. And number 10, the last one, which is the decane. So those are the 10 members of alkane, as the hydrocarbons. Okay, now here we are going to look at one example under the members of alkanes. Okay, so in this case we are going to write 3 isomers of alkane, of which one we are going to pick one member under alkanes. Okay, which is I'm just going to pick one under those, the one that I've highlighted 10 members. I'm just going to pick one, which is octane. Okay. Isomers of octane. So we understand to say these alkanes have got the general formula which all the members that have highlighted, those 10 members, they conform. So the general formula for octane is for this alkane, it is the CnH2n plus E2. So this is the general formula, meaning that all the members under octane correspond to this one. Okay, now here I started from methane up to decane, and this octane it has got 8 number of carbon, meaning that in this formula, where there is N, you substitute with the 8 because this one has got 80 carbons. Alright? Then we say, for us to write the molecular formula of this compound, meaning where there is N, we are going to put 8, and here we are going to put 8, so we have what we call the molecular formula of octane. Then here, so we're going to have C, we're going to have 8 there, hydrogen. Here, when we put 8 there, it means that we are going to say 2 multiplied by 8 times plus 2, isn't it? So here we are going to have 2 times 8, that is 16 plus 2, 18. Then we are going to have 18 like that. So this now becomes what we call the molecular formula of octane. Now, we write what we call the structural formula, like that. So now here, we write the structure of this one. First, when writing the structure, the carbon in this case, that is what we call the central carbon. It means that these hydrogens, they bond to the number of carbon. So carbon becomes the central atom of this compound. Okay? So when writing this one, the structure of this one, and then in the first place we define octane as the hydrocarbon that has got the single bond between carbon to carbon and carbon to hydrogen there. So there is only single bond. So we write the structure of this one. So there are 8 carbons here and 18 hydrogen like that. So I'm going to write 8 hydrogen like this. 1. Then we put single bond. So this means these are what we call the single bond between carbon to carbon. And then we also write another single bond between carbon to hydrogen. Now we start putting like this. We start putting those things there. So if you can check here, we have got the carbon to carbon as the single bond. And then we now start putting the hydrogen. So here we're going to put hydrogen, like that. Okay? Okay, so this one becomes the structure of octane. Now, we've not yet started answering what we call the isomers yet. We've just demonstrated the molecular formula and the structural formula there. If you can count, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 here, and carbon, there are 1, 2, 3, 4, 5, 6, 7, 8. So this is just it, the structural formula, and then this one, the molecular formula. Now, we present something there, okay? Okay, now, we write now the isomers. So, when we say isomers, it is just the shifting of carbons within this structure. Because